So let us start our discussion, very basic discussion today on jet propulsion system. They are also called as jet engines. So objectives of this video lecture is to introduce and define what we mean by jet propulsion system, and to explain working principle and basic classification of jet propulsion system. So as just we have seen, we have jet propulsion system. So before going into the detail, let us understand the meaning of each and every term. So let us start first with the definition of jet. A jet is a highly concentrated stream of fluid that is projected at very high velocity into a surrounding medium, usually from some kind of nozzle, aperture or orifice or very small hole. So that is called as jet. Jet can travel long distances without dissipating. If the stream of fluid, highly concentrated stream of fluid is coming out of a nozzle, let's say, in the form of jet, so that jet can travel at a very long distance without dissipating. Dissipating means its medium or fluid of that particular jet won't get mixed instantly with the surrounding medium. That is the meaning of dissipating. And jet fluid has higher momentum compared to the surrounding fluid medium. It has more momentum as compared to the surrounding medium in which it is being ejected. Like we say gas, jet of a gas, or water jet, or steam jet. Okay. Now propulsion. So what is propulsion? Propulsion is the action or process of pushing or pulling to drive an object in the forward direction. The word propulsion is derived from two Latin words. Pro, the first word is pro, meaning before or forwards, and peller meaning to drive. So the meaning of propulsion, the dictionary meaning of propulsion will be to drive an object or to push an object in the forward direction. That is the meaning of propulsion. A propulsion system consists of a source of mechanical power and a propulsion. What this propulsion does, it converts the power generated by mechanical power source into propulsive force, and this propulsive force pushes the object in the forward direction. So we have defined jet, we have defined propulsion. So let us combine these two words, jet propulsion. Jet propulsion is the propulsion of an object in one direction, particularly in forward direction, produced by ejecting a jet in the opposite direction. By Newton's third law, the moving body will be propelled in the opposite direction to that of jet. Jet propulsion is similar to the release of an inflated balloon. Every one of you must have played with the balloon. You fill the balloon by blowing the air into it with the help of your mouth. And when you release its mouth, the balloon travels randomly at very high velocity. So the same phenomena can be assimilated to the jet propulsion working principle. The inflated balloon has a compressed air pressing equally against all sides. So when you blow air into the balloon, this balloon has a compressed air and it presses the walls of the balloon in all possible directions. The air pushes out the open hole at the bottom. When you release the whole of the balloon, the air starts pushing out from this open hole. Now, what happens? The compressed air inside the balloon has ejecting from the open mouth. Now, there are two things which are important. First one is the action. What is that action? Air pushes out in one direction, and because of this action, there is a reaction. And what that reaction does? The reaction makes the balloon to flies or moves in the opposite direction of that of air coming out. So this phenomena is very similar to the jet propulsion process. Now, jet propulsion system. So we have defined jet, we have defined propulsion, we have defined jet propulsion, and now let us talk about jet propulsion system. A machine or system or engine that produces thrust to push an object in the forward direction using jet is called jet propulsion system. A gas or working fluid is accelerated by a machine or system or an engine, and the reaction to this acceleration produces a force or thrust on the machine, and this moves the machine in the forward direction. The amount of thrust depends on the mass flow through the engine and exit velocity of the gas. So by varying the mass flow rate and the velocity of the jet coming out from the machine, we can control or we can vary the thrust which is acting upon that machine to propel it in the forward direction. A jet engine is an engine that discharges a fast moving jet of fluid to generate thrust in accordance with Newton's third law of motion. Now let us discuss the working principle of jet propulsion system. How and why the jet propulsion system moves in the forward direction. So the working principle of jet propulsion system is based on Newton's law of motion. So there are two Newton's law of motion upon which the working principle of jet propulsion system is depending. First one is second law of motion. So according to the second law of motion, applied or generated thrust is directly proportional to the rate of change of momentum. The thrust acting upon the jet propulsion system is directly proportional to the rate of change of momentum of jet coming out from the jet propulsion system. And mathematically it can be calculated by F is equal to m into a, where a is acceleration and m is the mass of the fluid constituting a jet, and F is the thrust force. The second law on which the working principle of jet propulsion system is based is third law of motion, and it states that for every action there is an equal and opposite reaction. the reaction of the jet propels the unit in forward direction, that is opposite direction of the jet. So for example, let us consider this is any jet propulsion system. Okay, so jet is coming out from this jet propulsion system. So ejecting of the jet from this jet propulsion system is the action, and to this action there will be equal and opposite reaction, and this will create thrust. So this reaction will cause this jet propulsion system to move in this direction, to my rightward direction, which is exactly the opposite direction of the movement of the jet. Okay, so this is the working principle of jet propulsion system. To every action there is an equal and opposite reaction, and in jet propulsion system this reaction force will propel the jet propulsion system in the opposite direction of the movement of the motion of the jet. Now history of this jet propulsion system or various types of jet engines. So Sir Isaac Newton in the 18th century was the first to theorize that a rearward channeled explosion could propel a machine or system in the forward direction at a great rate of speed. And this theory was based on his third law of motion. As the hot air blasts backward through the nozzle moves in the forward direction. Henry Giffard built an airship which was powered by the first aircraft engine, a 3 horsepower steam engine. It was very heavy, too heavy to fly. So this was basically a conceptual prototype of the engine based upon the steam engine. The steam jet was coming out of the system, but the steam jet could not generate the sufficient thrust to move the system in the forward direction. In 1874, Felix de Temple built a monoplane that flew just a short hop down a hill with the help of a coal-fired steam engine. So this was another attempt to move a jet propulsion system based upon coal-fired steam engine. Once again here the steam jet was used to propel the system in the forward direction. Otto Daimler in the late 1800s invented the first gasoline engine. In 1903, the Wright brothers flew the Flyer with a 12 horsepower gas-powered engine. So this was a successful attempt to propel any jet propulsion system. From 1903, the year of the Wright brothers' first flight, to the late 1930s, the gas-powered reciprocating internal combustion engine with a propeller was the sole means used to propel the aircraft. So by the time of 1930s, inventors were able to design a jet propulsion system which was able to propel using the gas of a jet. Okay. It was Frank Whittle, a British pilot, who designed the first turbojet engine in 1930s. The first Whittle engine successfully flew in April 1937. This engine featured a multi-stage compressor and a combustion chamber, a single stage turbine and nozzle. And these components, what I have just mentioned, com compressor, combustion chamber, turbine and nozzle. These are the primary components of any jet engines. Even though now jet engines have been into the advanced stage, but these are the fundamental components of any jet engines. The first jet airplane to successfully use this type of engine was the German Henkel HE-178, invented by Hans von Hohen. It was the world's first turbojet powered flight. So it started with the Newton's theoretical engine and ended with Henkel HE-178. The turbojet engines have traveled or have transformed into more advanced forms nowadays. Now there are so many advanced jet engines which are capable to produce millions of thrust and have higher fuel efficiency to propel the aircrafts or various systems with a greater speed. Now classification of jet propulsion systems or jet engines. Jet propulsion systems are classified in many ways. So let us have a detailed classification. Jet propulsion systems or jet engines. So the very first type of jet propulsion system or jet engine is atmospheric jet engines. They are also called as air breathing engines. In atmospheric jet engines require atmospheric air for complete combustion of the fuel. As a result, their performance depends to a greater extent on the forward speed of the engine and upon the atmospheric pressure and temperature. All these three conditions, that is forward speed of the engine, atmospheric pressure and temperature, will govern the amount of air inhaled by the jet propulsion system. And we have discussed in the previous slide amount or mass of the fluid and speed of the jet propulsion system. Both govern the thrust produced by the jet propulsion system. So atmospheric jet engines are very much affected by the speed of the engine and atmospheric pressure and temperature. The second type of jet propulsion system is rocket engines, and they are called as non-air breathing engines. The rocket engines carry their own oxidizer for the combustion of the fuel and is therefore independent of atmospheric air and atmospheric pressure and temperature conditions. These engines requires maximum specific fuel consumption among all types of propulsion. Because what happens, the requirement of the thrust to propel the rocket engines to move against the gravity is tremendously high. Millions of thrust power is required to move the rocket engines and to launch them in the space against the gravity. So their specific fuel consumption will be very large as compared to all other types of jet propulsion system. Now atmospheric jet engines are further classified as number 1, steady combustion systems, and in this system there will be continuous airflow and combustion will be continuous. There are different types of steady combustion systems: turbojet, turbojet with afterburner, turbofan, turboprop, also known as propjet, and ramjet. Then atmospheric jet engine is further subclassified as intermittent combustion system or intermittent airflow. Here combustion will take place alternatively or intermittently. In one cycle, combustion will take place, and in another cycle, the combustion products will be utilized to generate the thrust and to propel the system in the forward direction. Pulse jet is the example of intermittent combustion type of jet propulsion system. It is also known as aeropulse, aerojet, semi-tube, and intermittent jet. So as we can see, jet propulsion system, atmospheric jet engines, rocket engines, and atmospheric jet engines are further classified as steady combustion systems or continuous airflow system, and intermittent combustion systems or intermittent airflow system. Now rocket engines are further subclassified as systems carrying solid propellant and system carrying liquid propellant. So this is all about the classification of jet propulsion system. In our syllabus, we are supposed to study in great details about atmospheric jet engines, both steady combustion system and intermittent combustion system. The rocket engines or non-air breathing engines are not there into your syllabus. So learning outcomes of this lecture: at the end of the lecture, you students as a learner will be able to introduce and define jet propulsion system and to explain working principle and classification of jet propulsion system or jet engines. In next lecture, I will be discussing about atmospheric jet engines or air breathing engines. So with this, I come to an end of this lecture. Thank you for your kind attention. Happy learning.